This video follows on from the one where I introduce the concept of place value and explain what happens if you don't have it and why it's important. And I'm going to actually give you some examples here and explain what it's all about and how we can use it to answer questions. For instance, here is a very large, pretty much random number. And what we might need to be able to do is to say what is the value of each of these digits in each of these positions. And as we know, the value of the digit varies depending on the position within the numeral. We have the same 10 digits from 0 to 9, and their value depends on where they are. For instance, at the end here, we know that the value of this digit is 6. These two are 56, so the value of that one is 50, the value of this one is 6. And it gets larger by a factor of 10 as we progress to the left through the number. It's a little bit more difficult to work out what the value is of these digits right up here in the number, but there are ways of doing it which are not too complicated, which I want to explain to you. Firstly, to help us, I've drawn up a table, and the table has lots of columns, and each column gives us the value of a digit which is in that particular column. Starting with 1 over here, units, going all the way along, tens, hundreds, thousands, 10,000s, 100,000s, millions, right the way up to 100 billion there. It doesn't stop there, but I couldn't go on forever. I'd be writing on the wallpaper, and we've got to stop somewhere. So I've just gone up to 100 billion. You'll notice there's a row underneath which has a figure 10 and a little number above it. If you're familiar with powers of 10, that will make sense to you. If not, you can still use it to make sense, because each of these little numbers at the top tells you how many zeros there would be in that particular number. As an example, if we have the number 1, there are no zeros after it at all. If we have the number 100, there would be 2 zeros. If I have the number 1 million, and I will just write that one in as an example, I would have 1, 0, 0, 0, 0, 0, 0. And if you look, I've got 1, 2, 3, 4, 5, 6 zeros. So you can just use that number at the top to predict how many zeros there would be in, for instance, 100 million would have 8 zeros. So just consider it to be that if you're not quite sure about what powers of 10 are all about. So I'll just rub off all these zeros and things. Now, as an example, we're going to use this very large number up here. And to help us work out what's going on, I'm going to write that number into this table. Now I know that that number has got the same number of digits as I've got columns in the table, so I can start at this end over here. 321604. 798 056. Okay. There's my big number. It's almost being obvious straight away, isn't it? This one is worth 6 units, 6 ones. This digit is worth 8 thousands, 8,000. Pick any digit you like, and you can see what it's worth. So, as an example, if you're asked to find the value of this digit, this 6 here, all I have to do is locate that 6 in my table here. It's there, so I'll put the arrow under here. Whoops, smashing my chalk. We've got a 6 there. It's got 8 figures after it, 1, 2, 3, 4, 5, 6, 7, 8, and therefore it's worth, a figure in that column is worth 100 million. So we've got 6 lots of 100 million. That therefore is worth 600 million. There's a clever way of working out what that actually is without having to go through all of this stuff if you know how to say these big numbers. And there's a separate video down here somewhere on how to pronounce and how to read very large numbers, because it's not actually all that tricky. And there's a simple way, really, of working out how to do that. But for the moment, let's just say we've got to say that that is worth 600 million. Now, without having all this table business, the first thing that we can do is we can write our number, 6, and we can imagine that all these other ones are actually zeros. and that will give us what that is actually worth. So wherever there's another number, another digit, for the rest of the numeral, we just replace it with a 0. So I've got 6, 0, 0, 0, 0, 0, 0, 0, 0. And that is a number. And if we know what that number is and how to say that, then that's the value of the digit 6 in that position. And the same goes for any of the other digits. So I'll do that over here. I'll put that underneath. I think I'll do it in red. So I've got 6, 0, 0, 0, 0, 0, 0, it's a bit dodgy, 0, 0. And in this case, we can see from the table that a digit in that position is worth 100 million. So I've got 600 million. We could just choose another digit in our number and try that again. Another example, let's take that one off. See if I can clear out some of that. Put my 6 back, it's disappeared. Right. Let's choose another one. Let's choose the 7 over there. So, imagine I want to know what that 7 is worth in my number. What I do, I find the 7 in this number here. It's just there. And I write it down here. I put some zeros after it. And that's what the 7 is worth. 700,000. Because that's 100,000. So 700,000 if the digit is in that position. And we can do that. We can work out the value of any digit by doing that. It's a bit of a nuisance to have to write out this table every time. Fair enough. But you do soon get the hang of what these things are. And it's quite easy to learn what those things are. I've removed that monstrously big 12-digit number because it's also important to know where to put a number in this sort of a table. So if we start with a number which is a slightly smaller one, let's have that number. The first thing you have to do is see how many digits there are in the number. 1, 2, 3, 4, 5. It's important to know that because we know that whatever that is, it's got a 2 at the end, and the 2 is units, isn't it? No matter what the rest of it is, the 2 has to be units. So it's no good writing it over here. That can't be right, because that would imply that the 2 is in fact 10 million. That would, the 2 is there, 20 million. It isn't, is it? So we have to arrange the number in our table, if you have a table, or however you're doing it, so that the 2 is in the units position, which means you must always line up the numbers starting from the right, which is a little unusual because when we're reading and doing anything else, we always start from the left. So lining up the numbers from the right is something you may have to think about a little whilst you get used to the concept. And it is one of the things that people quite often get wrong, which causes this sort of thing to go a bit haywire. So I count my digits, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, so it starts there in that column. 8, 7, 6, 5, 2 starts here. Now the number makes sense, now it fits, and I can do all the things that I was doing before about working out the value of each digit within that number. The 7, for instance, is worth thousands, so it's 7,000. Okay. Another thing you're quite often asked with regard to place value is to compare the size of two numbers. So I'll just get rid of this one. Just quickly rub that one off. If you were asked to compare the size of this number and this one, how much bigger is one than the other? You have to think, how many digits are there? How many powers of 10 are there? What's going on? I have, you'll notice, written that one underneath so the right-hand side lines up. If I put them in my big table over here, 1, 2, 3, 4 digits, so that one goes there. This one goes here. So what we've got there, how many powers of 10 is that one larger? That one is larger by 2 powers of 10. Okay, so you multiply it by 10 to get there, by 10 again to get here. And 10 times 10 is 100. So it's 100 larger, a factor of 100 larger than that one, and that one is 1/100th the size of that one. You can do this by seeing how many more zeros you've got on that one than you have on this one. This one has 1 0, that one has 3. And a number that has 2 zeros, because that's 2 zeros larger, a number that has 2 zeros on it is 100. So that one is therefore 100 times as big as that one. If it was 3 zeros bigger, it would be 1,000. And so forth. And you do occasionally get asked that kind of question. So we'll just do a couple more of those. Doesn't have to be, incidentally, a single digits like that. You might be asked that 73 and a few zeros, how much bigger is that than 73? And you can look at it and you think, well, we've got 4 zeros on that one. So that one is 1 and 4 zeros times that one. And 1 and 4 zeros, 1, 2, 3, 4, 1, 0, 0, 0, 0, is in fact 10,000. So that number is 10,000 times, that number rather is 10,000 times as big as that one. I'm trying to avoid reading these really large numbers because I don't want to try and explain that now. There's a separate video on reading very large numbers and writing them down here, which you might like to have a look at.